Dilations. A dilation is another type of transformation. We've already talked about two of them. The other transformations that we talked about are a translation, which is a slide, and a reflection, which is a flip. A dilation is a transformation that produces an image the same shape as its original, but it's a different size. A dilation can be an enlargement or a reduction of the original figure. Scale factor. We have talked about this before, but it's the number that you use to multiply the sides or coordinates by. So if the scale factor is 2, you multiply all your sides or your coordinates by 2. A figure and its dilation, they are considered similar figures. We have discussed similar figures previously. Enlargement that I mentioned earlier, the figure gets bigger. For you to have an enlargement, the scale factor must be larger than 1, and the same is true for a reduction, which gets smaller. The scale factor must be the opposite, smaller than 1. So it makes sense. If you've got a side that's 2 and you multiply it by 2, it gets bigger, it's 4. If you've got a side that's 4 and you multiply it by a half, well, it gets smaller, it becomes 2. So that makes sense. Here's an example of an enlargement. I've got a triangle that's 2, 2, and 4. And if I have a scale factor of 2, it becomes 4, 4, and 8. Here's an example of a reduction. I've got a rectangle that's a 9 by 3. And if my scale factor is 1/3, that means you multiply it by 1/3, or you can divide by 3. Your side of 9 becomes 3, and your side of 3 becomes 1. If you're ever trying to find the scale factor, you've got your two shapes but no scale factor. You can, if scale factor means to multiply, you can use division to find the scale factor. It is your new figure divided by your old figure. And here are some examples. And we're not always going to be given the picture. Sometimes we just have the coordinates. So example 1, I've got triangle ABC. And here are my coordinates, 0, 2, 2, 4, and 2, 8. If I've got a scale factor of 3, my scale factor is bigger than 1, so my shape should get larger. So over here I've got triangle A prime, B prime, C prime. So my first coordinate A is 0, 2. If I multiply both of those coordinates by 3, 0 times 3 is still 0, but 2 times 3 becomes 6. So A prime becomes 0, 6. 2, 4 is B. If I multiply both of those coordinates by 3, it becomes 6, 12. And coordinate C is 2, 8, so it becomes 6, 24. And I find that you'll find that if you graph triangle ABC and then you graph triangle A prime, B prime, C prime, that they look exactly the same, but your prime figure is much bigger, 3 times bigger. Example 2, I've got rectangle MNOP, and here are all my coordinates for each vertices, and I have a scale factor of 1/2. And you guys know that if you multiply something by a half, it's the same thing as dividing by 2. So coordinate M, 2 divided by 2 is 1. 2 divided by 2 is 1. So your M prime is 1, 1. And if you do that for each coordinate, your X coordinate and your Y coordinate on every vertices, you'll see that they are all cut in half. 8 divided by 2 is 4. 2 divided by 2 is 1. And that goes all the way down. And then if you were to graph rectangle MNOP, and then M prime, N prime, O prime, P prime, you will see that it is half the size of your original rectangle. So there's your dilations. We will complete the summary in class, so please bring your notes.